What if the physics that runs our entire world, from our phones to our power grids, is actually missing something? Today, we're diving into a really fascinating idea, that we've been using a simplified, almost edited version of reality. It's time to unlock the lost toolkit of physics.
So let's just start with a pretty provocative question. Is our standard model of electromagnetism the whole story? What if, for the sake of simplicity, we just intentionally threw away parts of the theory, parts that are physically real and could unlock technologies that sound like they're straight out of science fiction?
And to show you why this isn't just some academic debate, let's kick things off with a real-world, practical problem. Let's talk about sending a signal through walls.
I mean, really think about it. Imagine you're trying to communicate with a submarine, deep underwater, or maybe you need a sensor reading from inside a shielded nuclear reactor. Normally, things like water and metal just block electromagnetic signals flat out. But what if a signal existed that could completely ignore those shields? This isn't just speculation, by the way. It's a direct consequence of the physics we're about to unpack.
So, how on earth is this possible? Well, it all comes down to what's missing from our standard textbooks. Let's call it the case of the missing physics. 16. The complete, original theory of electromagnetism? Well, it isn't simple. It actually has 16 independent variables, or what physicists call degrees of freedom. The best way to think about it is like having 16 separate channels that can all carry information or create a physical effect.
And this diagram here, it shows you the whole picture. That matrix up top, that represents all the electromagnetic information possible in a system, all 16 of those components. Then, down below, you can see how that information gets broken up into two parts, a 6-component part and a 10-component part.
But the number we actually use in standard electrical engineering is just 6. We only use the information in that little blue box. So the question is obvious, right? Where did the other 10 components go?
Well, here's what happened. Those 16 components are split into two groups. The 6 on the left, those make up our familiar electric and magnetic fields, what we call E and B. The 10 components on the right, well, they were effectively deleted by a mathematical convention. Not because anyone proved they were physically meaningless, but simply because ignoring them made all the equations a lot simpler to solve.
And this wasn't an overnight thing. It happened over time, in what the source material calls 3 acts of deletion. First, a guy named Heaviside simplified Maxwell's original, more complex equations. Then, something called the Lorenz gauge was adopted as a mathematical convenience, which basically just sets a whole chunk of the physics to zero. And finally, the underlying potentials were demoted to just being mathematical tools, while the fields were declared to be the only real things that matter.
But here's the twist. The deleted information, these supposed ghosts in the machine, they are very, very real, and they have effects that we can actually measure.
So, the first real proof came from the wild world of quantum mechanics. In an experiment called the Aharonov-Bohm effect, an electron's path is literally altered by what's called a magnetic potential. That's the A on the diagram, even when it travels through a space where the magnetic field itself, the B, is absolute zero. This was a bombshell. It proved the electron was being affected by something our simplified theory said shouldn't even exist there. It was proof that the underlying potential was physically real.
But you might be thinking, okay, that's just some weird quantum quirk. But it's not. This thing has a classical macroscopic cousin called the Maxwell-Lodge effect. And even more importantly, there is industrial strength proof that this isn't just some lab curiosity.
And this isn't just a theory. I love how one source puts it. This effect is real enough to build patented industrial devices on. That statement moves this whole conversation from the physics lab directly to the engineer's workshop.
Check this out. This patented technology, the vector potential transformer, does exactly what that quantum experiment showed was possible. It uses a special coil to create a magnetic potential in a region where there is no magnetic field. And yet, a second coil placed in that field-free zone will still have a real, measurable voltage induced in it. This is the core principle behind the tech that can send signals through solid metal shields and deep into the ocean.
So what does this all mean for the future of engineering? It means we've been working with a limited toolkit this whole time. It's time to open up the expanded design space.
This slide really shows the whole paradigm shift. On the left, that's our current field primary world, limited to just 6 parameters, the electric and magnetic fields. And yeah, it's powerful, but it's incomplete.
On the right, that's the potential primary world, which uses all 16 parameters. This isn't just about adding a few more tools. This is a completely new way of thinking about engineering that unlocks capabilities the old model can't even begin to describe.
And you know that thing physicists call gauge freedom? It was always treated as this kind of mathematical nuisance, something you had to get rid of to make the equations work. Well, it turns out that's where the magic is. It's not redundancy, it is the untapped design space. It's basically the set of instructions for creating all these new effects that fields alone just can't produce.
Okay, so let's look at what this new approach really makes possible. What kind of technologies can we unlock when we use the complete 16-component toolkit?
First, we can create communication that is essentially immune to shielding. By engineering with potentials, we can generate something called scalar longitudinal waves. Now, unlike normal radio waves, these don't have a magnetic field component, and what that means is they don't induce currents in conductive materials, which lets them pass straight through Faraday cages and deep into the ocean without getting blocked.
Next is something that sounds like pure science fiction, but it has actually been demonstrated in labs, the Dynamical Casimir Effect. By rapidly changing a potential, not a field, a potential, you can essentially shake the fabric of the vacuum itself and create real particles of light, photons, literally out of nothing. This means we might be able to directly access the energy of the vacuum.
And it goes beyond just energy and communication. This gives us a much more fundamental level of control. By directly engineering with potentials, we can precisely manipulate the quantum phase of systems. This opens up all sorts of new possibilities in quantum computing and sensing, giving us a level of finesse and control that is simply impossible when you only think in terms of E and B fields.
And on an even bigger scale, this focus on potentials seems to reveal a deeper link between electromagnetism and gravity. Some theories are now suggesting that the electromagnetic potential isn't just like gravity, but could actually be a piece of the gravitational field that extends into a higher dimension. So we're not just talking about new gadgets here, we're talking about a more unified understanding of the entire universe.
So we have to end with this thought. For over a century, we've built our entire technological world on a simplified 6-component version of electromagnetism. We now know there are 10 more components with real engineerable effects. It really makes you wonder, if we did that to one of the most foundational pillars of physics, what other crucial degrees of freedom might we have simplified away in other fields? What other lost toolkits are just sitting there, waiting to be rediscovered?